Welcome everyone to another video series where we're gonna see how to integrate Modbus RTU protocol into our ControlLogix or CompactLogix PLC so we can read and write data back and forth to our slaves. So let's start. Now for the purpose of our implementation, we're going to have a ControlLogix PLC with an Ethernet module, and the way to implement the architecture in these circumstances so we can pick up our Modbus devices is we can have a serial to Ethernet converter between our RS-485 network and our Ethernet network. So we can bridge between the two. And then inside our ControlLogix or CompactLogix, we have these embedded add-on instruction that we're going to see here in a moment how it works, that will allow us or allow our PLC to natively communicate Modbus RTU. Now, since we are in a testing environment, I'm going to use my PC as basically the bridging device between my ControlLogix and for my slave I'm just using MDBus to simulate a Modbus slave, which we're going to see all that in a moment in here. Okay, as I mentioned earlier, so I'm using MDBus. And just to show you quickly what I've got in here, so I'm enabling the Modbus RTU via TCP protocol in here. It's set up as a slave, and I'm using port 502 to go through. And then here in my settings, I have 80 coils, 80 inputs or status, 50 input registers, and 50 holding registers. So those are the ones we're going to try to read and interact with from the PLC. So that's this all sets. I'm going to hit OK, and I'm going to turn this on. So now we have our slave is listening to the commands, and I'm going to minimize this for now. So if we have a look at our PLC program in here, so we've got like essentially just 3 rungs. So the first one, just to help us resume operation in case of communication errors and that type of things. The first rung here, or the second rung, essentially this is for reading Modbus slaves, so we can do function 1, 2, 3, and 4. And the last rung here is doing the writes for us, so we can do function 5, 6, 15, or 16, and we're going to see all that here in a moment. So just a bit on the settings, for example, of the read function. So we have set up here the gateway. So in our case, the gateway right now, as I mentioned, is just my PC, and I'm using port 502, which was set up in the MD bus. So that's my gateway, and the next setup here is we have the commands. So right now, to have a look at that, we can have up to 60 commands. But right now I have four commands set up. As you can see in here, they're indicated in the function block in here. So in the first command, basically I'm doing a function code 1. So I'm trying to read 80 coils in here. So reading the coils, and then the second command is I'm going to read the statuses, so that's function code number 2, so another 80. And then the third command is I'm trying to read the input registers, so the 50 registers. And then in the last command here, I'm trying to read the holding registers, so another 50 registers. So that's how the commands are set up. Now, one other thing I would like to mention here is we have this memory offset. So the add-on instruction has the ability to receive up to 120 registers. So what we mean by this is we're going to specify when we read these coils where they're going to be going into the add-on instruction. So in here we're saying start from basically element 0 of that array of 120 registers, and because this is a coil, so it's 80 coils, is going to occupy 5 registers because every register is 16 bits. And then in the same way we have the statuses, so 80 coils is going to occupy another 5. So that's why you will notice here I'm starting from 5. So from 0 to 4 is occupied by the first command, and then the second command is going to occupy another 5, so that'll be 5 to 9. And then you will notice here in the following command I'm starting from 10. Now in here we have from 10, and we are trying to read 50 registers, so that's why in the last command I'm starting from 60. So that's how that works. Okay, so without any further delay, let's trigger this and see how it's gonna work for us. So everything here is good, so okay. So I'm just gonna trigger this, and it says here it's connected, and it's updating itself, and then it's gonna restart, and there we go. So now it's active and reading. So now to confirm we're getting the reading and all that is good, so what I'm gonna do is I'm gonna bring this read data array so we can see it with the MDBus values. So we can grab just that. RTU, gonna put the read. Okay, so this is our array we talked about earlier. So we have 120 registers. So I'm gonna bring that up in here, and let's just put that aside like that. And then we can see here we already have, you know, the commands are going for us in here, as we can see. So I'm going to close this for now, and I'm going to bring first I'm going to bring our coils that we were trying to read. So minimize that for a second, put that a little bit down like that. So as we mentioned, this coils, because we're reading 80 coils, is going to occupy essentially these first 4 registers. So if we see here we have 0, 1, 1, 1, 0. If we open up the first register, you can see it's matching 0, 1, 1, and then 0, 0, 1, which is matching what we have in here. Now if we go here and let's say we set up this to 1, we will see here that this will change to 1 like we saw right there, and then we can change this to 0, and then this will change to 0, update, there we go, and then accept, next one, put it to 0, and there we go, it's changed to 0. Now in the same way we can go to the last one here just to show you quickly. So this one is the, let's say this bit, which is coil 80. So if I go here to this coil 80, right now it's 1, which is correspond to this one here. So if I put this to 0, it's gonna update here a couple seconds. There we go, it's changed to 0. So that's for reading our coils. Now let's see about reading our statuses. So I'm going to close this for a moment and then go back to our MDBus and bring the statuses this time. and I'm going to bring it here. Let's minimize this for a second. Now in the same way, now we said we're going to be starting from 5. So now if we look here, we see here we have our coils in here. So we have like 1, 1, 1, the first ones, the first 4 bits. And if we go up in here, we see the first 4 ones are also 1, 1, 1. Now if we go here and let's say we change this to 0, or sorry, I should change it here. So we change that to 0, so accept. We'll see here, this will update here in a second. There we go. And then in the same way, we can update this to 0. See, there we go, it's changed to 0. Next one, we can put it to 0. And then we'll see the third one is going to update to 0 here in a second. There we go. And now in the same way, we can grab the last one here, which will be in register 9, this last bit right there. If we grab this and we change it to 0, so here it's changed to 0, and then it's going to update here in a second. There we go, so it changed to 0. So that's how we can read our coils. Now let's have a look at our input registers. So I'm gonna close this and go to display our input registers. So in the same way, we can go like there, minimize this. And then we'll see here we have 50 registers. So now for the registers, as we said, we're starting from 10. So like right away, we can see it's 100 and 200, so it's already reading these. So now if I go here and change this 100 to something like 1001 maybe, or something like that. So we're going to see this will update. And then in the same way, we can do maybe 2001. Accept. So as we see here, this is updates. Update gets updated to 1001. And then we'll have this updated 2001, and then in the same way, next one. Now keep in mind we have the polling intervals set, I think 2-3 seconds, so it takes a few seconds to update, but if we want to speed up that, we can also do so. So there we go, let's update that. Now if we look at the last one, which will be 59 right there, so it's 1000, we can see it's 1000 in here. If we go here and say we're going to change it to maybe 10, hit accept, we'll see here it's going to update here in a couple seconds. So that's 10 in here, and then in our last register here, there we go, so it changed to 10. So that's, we're reading now our input registers. So now let's look at our holding registers. I'm going to close that, close this same way. We're going to bring our holding registers. And again, we have 50 registers that we're trying to read. There we go. So as you can see here, we're starting from 60, which is over here. I'm going to put this a little bit up. So as you can see here, we have 1, 2 already, it's reading. If I go here and maybe put this to 10, accept, and then put this 20, accept, maybe 30, accept, and then 40, accept, and we can see that we already have the 10, 20, 30 is already updated, and then 40 is going to be updated here in a moment. And there we go. And then in the same way, we can go to the last register, which is 109, and then we can change this maybe to 500, for example, and then we're going to see this one here updated. There we go, 500. So that's simple as that, how we can basically do all the read functions using our add-on instruction. So now in the same way, we are going to see the write function and how all that will work. So I'm just going to minimize this for a second. So let's have a look at our write function. So similar to the read functions, it has the same settings, except this ones we do the right functions like 5, 6, 15 and 16. So we have the same gateway we're talking to in here, and then we have the commands. So the first one we set up is command 5. So we just want to write to a single coil, and it's going to start from basically the right is 0 in the right array, which is again another 120 registers. And then the following command is 6, so we just want to write to a single register, and the address we want to write to is the last one, which is 50, and then the one we want to write from is register 1 in here. And then in the third command, it's function 15, so we just want to write to multiple coils. In here we just specify 10 coils, and we're going to start from register number 2. And then the last command is writing to holding registers, so we're going to write 20 registers. We're going to start from 3 in the register we're writing from, and then we're starting for the functions in here from 0. So those are the commands we want to do. So let's see how that's going to all work. So I'm going to click OK. I'm going to trigger this, and then it's going to verify itself, go through its sequence, and then it's going to update and start. And as we see here, so now it's connected, it's active and all that. So let's go to our write data register in here, our array I should say. I'm going to bring it in here, and this time is going to be the write. Alright, so this is our write, and I'm going to put it back in here, and then in the same way we're going to bring our coils. So the first command, like we said, it's going to be just writing to a single coil, so this first coil right here. So right now it's 0. If I put here a 1, we'll see here now it's 1. If I put 0, we'll see here it update to 0. So there's 0, 0. If I put it back to 1, it's going to write 1 right there. Now the next command is, we said we want to write to a single register, and if you remember, the address was 49, which is 50 because it's offset of 1. So that's the last register. So we want to bring our holding registers. So I'm going to just bring it in here, just put it beside this one, and we're going to see here, make it a little bit longer. Okay, so it's 5,000. You see 5,000 here, so I can put here to maybe 1,500 for example, and then it's going to update this last one here for us, like you saw here. So now it's 1,500. And then the following command, we said we want to write to multiple coils. So starting from basically this one here too. So we're going to bring this up. As we can see here, we have 1, 1, 1, and 0, 0, 1, and it's the same what we have in here. Now if I put here 0, for example, you will see immediately this turned to 0. Put the next one to 0, there we go, 0. I'll put this to 0, and now there we go, 0. I can put also this one to 0, which is correspond to this one, there we go, 0. Now if I put this to 1, it will turn the one beneath it here to 1 right there. And then if I go back and put this to 1, it will turn this one to 1 right there. Okay, so that's as simple as that. Now the following command is, we said we want to write to 20 registers starting from this register 3. So as we can see here, we have 1, 2, 3, 4, and so forth that we're writing to these registers. So now if I change this to maybe 100, 101, 102, 103, 104, 105, 106. So as we can see here, it's updating as we go. So we have 105, 106. There we go, 105, 106, and we want to write all the way to basically 20 registers. So we can put here 1110, for example, and that's going to update right there for us, and so forth. So 120, 130, so forth. So there we go. So it was just as simple as that. So as you saw here, we are able to do read functions and write functions in our PLC without a need of basically any third-party gateway and so forth, except I guess the serial server, because we have to convert the medium from serial to Ethernet. And the other thing also to keep in mind in here is you can communicate to multiple gateways if needed, because you can just add these more add-on instructions in your logic, and you'll be able to communicate to other gateways as well simultaneously. The other thing I would like to mention is you can watch the video that is in the description of this video, so you can see how you can get your trial version of these add-on instructions to play with them and interact with them, or perhaps get your permanent one. And again, thank you very much for watching this video, and if you enjoyed the content, please subscribe and like, comment, all will be appreciated.